Hello, everybody. We have another visual pattern challenge today. So here is our pattern. Here's step one of the pattern. Here's step two, step three. They've even given us a fourth step. And the challenge for you is to figure out how many of these blocks are going to be in step number 5. And then if you can, how many in step 43? That's a little more difficult. And can you write an equation that you could use to predict the number of blocks in any step at all? So that's the challenge. If you'd like to accept that, pause the video, give it a try. All right, so I think this is a three-dimensional pattern, but I think we can see all the blocks. It looks like there's one here, and that would be this one right here. And it looks like we've added on the top, behind, and to the right. So we've added 3 there. And in the next pattern, these are the blocks that were previously there, and it looks like we've added 1 on the top, 1 behind, and 1 to the right again. So it looks like we're adding 3 more every time. And let's see, here's that L. Yeah, so that's a kind of a 3 wide L with a tail. And then we've added this one and this one and this one. So if I wanted to predict for step 5 just by using this visual intuition, I'd add a block up here, a block over here, and a block over here. And how many would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I think there are 13 in whoops, not in step 4, but in step 5. In step 4, we've got 10, right? Because it's 3 less than that, those 3 that I added. And this one would be 7. And this one would be 1, 2, 3, 4. And that's 1 block, obviously. Okay, so we're adding the same number of blocks every turn. So I think this is going to be a linear pattern. Let's just double check that. We'll be careful by plotting it out in a little chart here. I'll put down the step number and the number of blocks in each step. So in step 1, we have 1. In step 2, we have 4. In step 3, we have 7. In step 4, we have 10. And in step 5, we're predicting 13. And then what we do once we've got the numbers is we find the differences. How much is it increasing by? So 4 minus 1 would be 3. 7 minus 4, 3 again. 10 minus 7, 3. 13 minus 10, 3. And when the differences are all the same, you can be pretty sure that this is a linear pattern. And we can use the equation for a line to model it. So y equals mx plus b is that equation we usually use for a line. And the m represents the slope of the line, or in the case of a pattern like this, it represents the change in each step. So that change is 3 blocks. X will represent the step number. And then this plus b, it's some other number that we might need to use to adjust things if this doesn't quite work out. So let's look how it would work out. If we did 3 times x, and x is the step number, 3 times 1. If that's all the equation was, 3 times 1 is 3, this would be predicting there are 3 blocks in step 1, but there's only 1. So to adjust that, our b is going to have to be a negative 2. Now this would be 3 times 1, which is 3, minus 2, that equals 1, and that's how many blocks we have there. So our equation would be y equals 3x minus 2. Let's double check this. Let's try it for step 2. So y would equal 3 times step 2 minus 2. That's 3 times 2 is 6, minus 2 is 4. That's working out. Let's see if it works with step 4. So y equals 3 times step 4 minus 2. And 3 times 4 is 12, minus 2 is 10. Yep, that's how many we have in step 4. So I think we can be pretty sure about our equation, y equals 3x minus 2. And we did figure out how many in step 5, that's 13. So now we can use this equation to figure out how many in step 43. So we'll just plug in 43 for the step number, which is x. So y equals 3 times 43 minus 2. 3 times 43, let's see, 3 times 40 would be 120, 3 times 3 would be 9, so that's 129, minus 2 would be 127 blocks in step number 43. Well, did you get that one? Did you get step 5? Did you get step 43? Let me know. Thanks, everybody.